Geometry section 1.3, talking about angle measurements. In the previous section, we talked about segments and segment measurements. This is a similar concept as the previous section, but instead of segments, they're angles. Angles are inherently more complicated because the way you name angles are more complicated. So before we get into angles, let's get back to some things that we had discussed previously and build what an angle is. A ray, as we learned previously, is a segment that extends indefinitely, that means forever, in one direction. So let's say that this is ray RA. We could name this, actually, have we talked about rays? Yeah, we did. First section we talked about rays, but let's revisit it again. We could call this ray RA. We could also call this ray RY, that's the same ray. We could name it ray RA in this way, or we could name it ray RY in this way. The vertex is the endpoint of the ray. So in this case, R is the vertex. An angle is a figure, that means a picture, that consists of two rays with a common endpoint, a common vertex. And sides are the two rays of the angle. So for example, if I draw this ray AB, and then I draw this ray AC, lots of things can be said about this. Let me just add one more thing. If let's say that I had a number in here, but no degree symbol, just a number. I could name this angle BAC. The order kind of matters. This middle letter has to be the vertex. The vertex is where the two rays intersect. It's the endpoint of a ray. I could call this same angle CAB. Middle letter is the same. I chose one letter on one ray and one letter on the other ray. I could even call this angle A, because A is the vertex. They might be thinking, why would I ever use three letters when I could use one? Well, there are some instances where you have to use three letters because it's not obvious which angle you're talking about. We will get to that when we get to that. We could also call this angle 1 if you're fortunate enough to have a little number inside the angle that is not the degree measure, but just representing, hey, this is angle 1. As regards to sides, we could say that ray AB and ray AC are sides of the angle. Interior and exterior of an angle. It's difficult to put this into words, so let me just try to highlight this. This purple region is the interior of the angle. This green region is the exterior of the angle. So this is the interior, this is the exterior. Measure of an angle, super important. The number of degrees in an angle. So for example, let's say that we have this angle here, angle J, and we're told, notice this is kind of like an arc with an arrow on it, essentially what this is, and we're told this is 30 degrees. We could say, in a terrible way, the measure, it's terrible because it's so much writing. Angle J is equal to 30 degrees. Or we could say the measure of angle J is 30 degrees. This is much better because it's much less work. However, we could say it like this, and that's also accurate. Notice, once again, measures are equal. If I say the measure of a segment, it means the length of the segment. If I say the measure of an angle, it means how far open this angle is. It's 30 degrees. Opposite rays and straight angle. Opposite rays, previous term, two collinear rays that extend in opposite directions. straight angle is the picture formed by two opposite rays. So if I draw, which ends up essentially being a line, I put if I name 3 points on this, so we got, just highlighting these two different rays, we could say that segment BA and segment BC are opposite rays. This is old information being told to you in the exact same way I told you to you before. But a straight angle is new information. Straight angle, we could say the angle ABC is a straight angle. The figure that's formed is a straight angle. Each individual ray is an opposite ray. Very similar things, but they're in fact different. Acute angle, obtuse angle, right angle. An acute angle is an angle whose measure is less than 90 degrees and greater than 0 degrees. So an acute angle is less than 90 degrees, but it's larger than 0 degrees. An obtuse angle is an angle whose measure is greater than 90 degrees and less than 180 degrees. A right angle is an angle whose measure is exactly 90 degrees. Acute, between 0 and 90 degrees. Obtuse, between 90 and 180 degrees. A right angle is 90 degrees. What if it's exactly 180? We've already learned that. That's straight angle. I guess we didn't actually learn it. We discussed it was 180, but it's 180, and we will get to that formally at some point. Congruent angles. Now this should look familiar because we had the definition in the previous section of congruent segments. It's how we started section 1.2. It's the same concept, but we're talking about angles. Angle cat is congruent to angle dog. These are talking about pictures, means they're the exact same shape and size. If and only if the measure of angle cat is equal to the measure of angle dog. The measures are numbers, equal signs are numbers. So let me give you some pictures of this, and we'll try to simplify this a little bit. So here is a picture of angle cat. Here is a picture of angle dog. My angles are not very attractive. Let's do it like this. All right. For me to show in the picture that they are congruent, I can put the same number of arcs without an arrow. An arc with an arrow is just pointing something out. An arc without an arrow is saying that these two things are congruent. So if they both had 3 arcs, they're congruent. They both have 1 arc, they're congruent. There's other ways to show that they're congruent. We'll get to that in a bit. From this picture, I could say if angle A is congruent to angle O, then we know that the measure of angle A is equal to the measure of angle O. I could say this backwards and say if the measure of angle O, A I should say, is equal to the measure of angle O, then angle A is congruent to angle O. It's the same thing that it says up here, but instead of using 3 letters to name the angle, I just used 1. I wanted to make this clear again. This is talking about the picture of angles are congruent. This is talking about the measures of the angles are equal. Equal versus congruent. The debate continues. Not really a debate, but a very subtle difference between the two. So in this picture, let me draw another angle here. You do the same, please. Let's say this is angle B, and let's say it's also 52 degrees. The measure of angle dog is equal to 52 degrees. Angle dog is congruent to angle B. Angles are congruent. Measures of angles are equal to numbers. Check out this picture. Measure of angle A is 70 degrees. So I'm going to put a little 70 degrees where that angle is. Measure of angle BCA, also 70 degrees. I'm going to put that there. Now, I could say angle A is congruent to angle C. I could say the measure of angle A is equal to the measure of angle C, which is equal to 70 degrees. Angles are pictures which are congruent. Measures of angles are numbers which are equals. Isosceles triangle, something you don't have to know yet, but essentially an isosceles triangle is a triangle in which at least two sides are the same length. So if we're told that angle 1 and 2 are congruent, I don't even have 1 and 2 in the picture. Let's say this is angle 1 and angle 2. If we're told they're congruent, we can put the same number of arcs in these angles, and that's just showing you those are congruent. The measures of angle 1 is equal to the measure of angle 2. This is not a different example than this. It's just a different way of showing it, but it's redundant. Angle bisector. We had segment bisector yesterday. Segment bisector means that the segment is being cut in half, goes through the midpoint by some other line, segment, or plane. Angle bisector is a line, ray, or segment that separates an angle into two congruent angles. So let's draw an angle. We'll call this angle dog. If I were to draw a ray that went through this angle, let's say ray OD, I already have a D, OB, in such a way that this angle is congruent to this angle. You don't have to just use arcs to show the angles are congruent. You can make the same little picture in each of those, and that means they're congruent as well. So we could say that segment OB bisects angle ABC. I'm sorry, it's not angle ABC. It's angle DOG. Therefore, three dots like this, once again, mathematicians are the laziest pieces of garbage on the earth. That's the word therefore. Too many letters, so we use three dots. Therefore, angle DOB is congruent to angle BOG. Now, you might be thinking, why are you using three letters, man? You said earlier we could use one letter. It's true, but in this picture, if I say angle O, which angle do I mean? Do I mean this angle? Do I mean this angle? Do I mean this angle? We have multiple angles at the same vertex. When that happens, you must use three letters. The middle letter is the vertex. Notice in each of these, O is the middle letter. And then to figure out what angle you're going to use, or what letter you're going to use, pick a letter on one of the rays. So I go from D to O to B, so it's angle DOB. I go from B to O to G, so it's BOG. For this one, I go from D to O to G, so it's angle DOG. All right, that's pretty much it for our terminology. Estimate, measure, and classify each angle using a protractor. I'm just going to highlight this so that when I put my protractor over top of this, I can still see it. Here's my protractor. Here's what you're going to do. You're going to take this part of the protractor, this And everyone's protractor could be a little bit different. Mine has this T represents the center. I'm going to put that over top of this point. I'm then going to rotate this protractor so that one of my rays lines up with 0. So notice center here is on the vertex. One of my rays lines up with 0. Starting from 0, I count up to this other ray. So it looks like 10, 20, 30, 40. I'm estimating maybe a 44. So I'm going to estimate this is 44 degrees. Maybe you got 43 degrees or 42 or 47. That's fine. I would give you like a 3-degree tolerance in either direction from where mine is, and we could say that it's correct. So someone else might look at this and say, you know what? I think this is 136 degrees. There's 2 reasons why it doesn't make sense. This is clearly less than 90. So the number we should have should be less than 90. Also, you start wherever the protractor points at 0. This is pointing at 0 and 180. Start at the 0 and count. If we're pointing at this 0 on the outside, then we would count this way. Estimate. So we didn't estimate. So I apologize. We first were supposed to, hey, guess what this angle is, then measure it, then classify it. I skipped the first part. I apologize. How do we classify it? Is it acute, obtuse, or right? This is an acute angle because it's between 0 and 90 degrees. Let's see if we can follow the directions for this next one. Let's first estimate it. How many degrees do you think this is? I'm just going to estimate. It's clearly bigger than 90. Hope you can see that. It's not a lot bigger than 90. I'm going to guess 110 degrees. Now let's measure it. I got to outline this first because if I don't, I won't be able to see my lines because this protractor is not transparent. I missed this a little bit. If my line that I'm drawing here is off just a little bit, it's going to change this angle measure, possibly a lot. So I'm going to pull this over, and I want to rotate it. I want my vertex on the vertex, and I want one of my rays pointing at 0. It looks like this measurement here, starting at 0, it's going to go up here to 90, 100. Here's 110, about halfway through. Looks like it might be around 105 degrees. This is an obtuse angle because it's bigger than 90 degrees and less than 180. All right, let's check out this next picture, see what we understand about angles. Angle CBJ, CBJ. That's this angle right here. Is congruent to, is there another angle in this that has 2 arcs? Sure, it's right here. You can name that angle in a couple ways. You could say DHG, you could say FHG, you could go in the opposite direction. I will say angle FHG. They both have 2 arcs, they're congruent. Angle FJH, FJH, that's this angle here. It's got 3 arcs. Is there another angle that has 3 arcs? Sure does. Angle AJB, AJB. You could also say it in the opposite order. Oh, this next one, maybe it's a little bit of math involved here. I haven't used really numbers yet today. If the measure of angle EFD is 75, when you read this, that's supposed to be degrees, by the way. When you read this, put it into the picture. Measure of angle EFD, so EFD, 75 degrees. Then what do you think the measure of angle JAB is? Here's JAB. Oy, they both have 1 arc. By the definition of congruent angles, their measures have to be the same. So it is also 75 degrees. 11 GHF, angle GHF, that's got two arcs, is 130 degrees. Let's put that into our drawing. What's the measure of angle JBC? That's also got two arcs. So I guess that's also 130. All right, let's see if we can get to some real thick geometry problems. And here's a real thick geometry problem. Ray AT is the angle bisector of angle MA. To show that ray AT is the angle bisector of angle MA, we have to put this into our picture. To bisect the angle means it cuts into two equal parts. So I am going to put a star on each of these. It's also the picture that's on the flag of the TV show Community, if you ever watched that show. Don't know if you've ever seen it. Good show. It's on Netflix. Measure of angle MAT is 60 degrees. I'm going to put an arc with an arrow on it. That doesn't mean congruent. It just means I'm pointing out the angle. Measure of angle ta, 4x plus 20. I'm not saying this are congruent, even though they are, because they have those little stars there. This is 4x plus 20. Find the measure of angle, or find the measure of x. We don't typically pay much attention to the question when we're doing these problems. We put the information into the picture. We then make an equation from the picture, and then we worry about what the question is. According to the definition of congruent angles, since these two angles are congruent, it means their measures, the measure of angle MAT, is going to equal the measure of angle ta. Now we know from our picture the measure of angle MAT is 60 degrees. You don't have to put the degrees in. And the measure of angle ta is 4x plus 20 degrees. You don't have to put the degrees in. Now it's simple algebra. We're going to subtract 20 from both sides. We're going to divide both sides by 4, and we get x is 10. Once you know what x is, then focus on the question. Question, find the value of x. We've got it. It's 10. We move on. It's got two questions. Number 13, given angle LOV is congruent to angle val, I'm going to put one arc on each of these to show that they're congruent. No arrow, that means congruent. Measure of angle love, 7x minus 14. Put that right on that little arc. Measure of angle VOW is 3x plus 12. Put that on that little arc. Find the value of x. Let's make an equation first with letters. We can say the measure of angle LOV is equal to the measure of angle VOW. How can we say that? Definition of congruent. If the angles are congruent, then their measures are equal. Then we can substitute. Measure of angle love is 7x minus 14. Measure of angle val is 3x plus 12. If we subtract 3x from both sides, we get 4x minus 14 equals 12. If we add 14 to both sides, we get 4x is 26. If we divide both sides by 4, usually I leave things as a fraction. This would be 26 over 4, which reduces to 13 over 2. But if that ends up being a decimal, that's not a nasty decimal. I'll change it to a decimal. 6.5. Find the value of x. Hey, we did that. Find the measure of angle LOV. Well, the measure of angle LOV, according to our picture, is equal to 7x minus 14. So we get 7 times 6.5 minus 14. 7 times 6.5 is 45.5. You subtract 14 from that, you're going to get 31.5. All right, Well, that concludes the notes. Thank you very much. Do the assignment that's listed on the web.